Okay, let me continue. Last time, before the Chuseok holiday, we finished until this part. Yeah. So the next visualization, I think I will just briefly give you the idea about the visualization. There are some techniques. We call it geometric projection. Geometric projection means we use the geometric visualization of the geometric transformation and projection of the data. And some methods, I think you already know about the scatter plot. And there can be matrices, scatterplot matrices. And some other methods like parallel coordinates. This is, we call it as the scatterplot matrices. Here, if you still remember the iris dataset, we can plot between two different attributes. We have the sepal length, petal length, sepal width, petal width. And we can plot all of them at once. So here, sepal length, petal length, sepal width, petal width. So if you look at this diagram, it means we can see the correlation between sepal length, because this is in the column of sepal length, and this belongs to the petal length for the y-axis. If you look at this box, then this is the correlation between the sepal length and the sepal width. So we call this is the scatterplot matrices. If your data are numerical attributes, so you can see this kind of matrix as much as the number of your attributes. And the iris dataset, you can see that we have 4 numerical attributes. So we have the sepal length, petal length, and sepal width and petal width. Other things about the geometric visualization, we call it as the parallel coordinates. In this case, I think is we can see this is the x, and there can be multiple y. So if we have multiple y, then we can just plot what is the y1, what is y2, y3, y4, and so on. And when x equals to 2, we can also see for every of the y. When x equals to 3, we can see every for of the y. And usually this kind of data is a kind of time series. So we can see where is the minimum. This is the minimum. And where is the maximum? This is the maximum. This is the maximum. This is the minimum. This is the maximum. This is the minimum. Using this kind of time series, or if we have several y data, we can use these parallel coordinates. Icon-based visualization techniques. This is also a good approach to visualize the data. We want to use pictures of icons. So icons means small picture. There are some typical visualization methods. These are very traditional techniques. We call it Chernoff Faces. There are also another kind of visualization methods we call stick figures. Some other general techniques, they call it shape coding. So use shape to represent certain information encoding. It means we have some shape, maybe triangle or box, okay, or rectangle, or we can use color. If the color is red, then maybe it is dangerous. If the color is green, it is safe. So something like that. This is an example of Chernoff Faces. So the researchers, they developed this kind of Chernoff faces to display variables on two-dimensional surface. So let X be the eyebrow. So X, this one, and Y be the eye size. Okay, you can see the eye size, and Z be the nose length. You can see the nose here, and etc. So every of the attribute can be represented in the face. We call this is the Chernoff faces. And usually, in this figure, we can produce 10 characteristics. You can see the head. The head eccentricity is different. This head and this head is different. And the eye size, eye spacing. So between the two eyes, it has some distance. So it means they have different values. And then the eye eccentricity, the shape of the eye. Pupil size. So you can see the dot. Yeah. This is very small. This is a bit bigger. Eyebrow slant. This eyebrow is horizontal. This a little bit have a slope. Okay, so it has different meaning. And so on about nose size, mouth shape, mouth size, and mouth opening. So it means it can have 10 possible values. So you can check some of the books that use this kind of visualization. In this book, The Cartoon Guide to Statistics, or some tools like Mathematica and Math World from, they use this kind of visualization. Stick figure. This is also a very unique visualization. This represents a census data. Census data, it shows the age, income, gender, education, and so on at the same time. So the data item, we have 5-piece stick figure. So maybe it's too small. You can see, this one, it has 5 sticks. There's one body and 4 limbs with different angle or length. So they have like body, and there can be some limbs like this one. Maybe something like this one. The attribute that had been used here are 2 attributes mapped to the axis, which is income and age, and the remaining attributes mapped to the angle or length of the limbs. So let's say we have this income. We have, this is the age. And then the higher income. And then you can see the older the age. And we can see what are the gender. So the limb here, the limb is like the hand here. it represents the gender, or maybe it represents the education. So in one graph, the detail can be seen in these figures. So we call this is the stick figure. It is only the summary, so you cannot see more detail. Another way to do the visualization, we call it the hierarchical partitioning. Visualization of the data using a hierarchical partitioning into subspaces. We have dimensional stacking. We have worlds within worlds, tree map, and I think I will skip these two, countries and InfoCube. I will skip those two. So let's see. In the dimensional stacking, we can see some matrix or table like this. We have the attribute 2, we have attribute 1, and we can represent it in the table. If we want to look into the details, we can focus on this, and then we can look at the details. For example, if the attribute 1 is about the city, and then the attribute 2 maybe is about the season. So we want to see the temperature of the city and the season. And then we can focus more. Let's see in this detail. I want to see more details, not on the city, but maybe based on the district. In Korea, like Yongin-si, we have Musun-dong, Gu, okay, Musun-myeon. So we can make more details on the specific area. Or we can make a specific attribute. Maybe we have winter season, we have fall, we have summer. So on summer, we have 3 months, June, July, August. So we can make more specific on that attribute. So we call this is the dimensional stacking. We can make subspace, so it is more detailed. This is also another dimensional stacking. This is a visualization of oil mining data with longitude and latitude mapped to the outer x and y axis, and our grid and depth mapped to the inner x and y axis. So this can be the latitude. This can be the longitude. And this represents the area where you can see the oil. So in this area, the oil is more than the other area. Then you can focus on mining in this area for the oil. In this area, we have a very small amount of oil. This area, we have small amount of oil. So yeah, then we can focus on this area if we want to mine the oil. Because this is the dimensional stacking. Worlds within worlds. This is another way to express the attributes. Let's say this one, yeah, I use the Korean, Hanyul, the currency, and then X2 is GDP. And I would like to see if we have the sales. And then we have the X3, another variable is the inflation. And then the price index, and so on. So we can also put another variables into one graph like this one. And this is of course a little bit complicated because you are combining the X1 you're combining the X1, you're combining the X2, X3, X4, and X5 in the same graph. We call this is the N-fission. So the dynamic interaction through the data cloth and zero display. You can rotate, or you can make another scaling, or you can make a translation. Because this is the words within words. Tree map. I think this is a common ways to express words or news. When you have a news, you may represent in the color. So let's say this color represent maybe about the international news. And this color, maybe it represent the economics. This color represent about the international security. We can express every news in different color, in a specific color, and we can put the important news with bigger font. The small font, maybe it is not that popular, or maybe it is less important than the bigger font. And we can make the attributes. This is maybe you can see this one, the color. It represents some of the category. And based on this category, you can easily see the news and you can select what are the proper news for you. Maybe about the business or about the technology or sports, entertainment, health, and etc. We call this graph or this visualization as the tree map. If you want to visualize complex data and you want to see some relationship, so usually when we are dealing with the complex data, we are going to visualize non-numerical data. The non-numerical data means the categorical data. It can be text, because text contain a lot of string. Text contain a lot of words. Or maybe it is related with the social network. If you use Instagram, you know that you can use tag. Okay? And when you use tag, we can generate the tag into some topics. So we can visualize the user generated text. Like in Twitter, every day they give what is the most popular topic based on the tag. So we can also refer to this kind of tree map. The importance of the tag is represented by font size or color. And besides the text data, there are also methods to visualize relationship, such as visualizing social networks. So like this one, we call this is a kind of relations, and we can see also like a social network. What is the meaning by this one? Maybe you know in the health, we have high blood pressure. allergies, overweight, high cholesterol level, and so on. So those are the diseases. And I would like to see what are the relations between one disease and other diseases. So let's see, this is the HB. HB is the high blood pressure. Go here up. And I want to see, is there any relationship with other diseases? Oh, there's a relationship with TR. TR is trouble seeing. Okay, there can be a relation between those two. And then HC. Okay, there is a relationship between the HB and the high cholesterol level. AR, arthritis, and so on. Okay. So with this graph, we can see what is the relationship between the disease. Byung Van Wei, like that. Okay, so I would like you to prepare the Jupyter notebook, Jupyter lab. Okay, for next 2 weeks, we will practice a little bit how to use the Jupyter lab or Jupyter notebook for our course. Yeah, that's the brief about the visualization techniques. Maybe we will not use all the visualization techniques in our course, but I hope that it can give you some sense. What are the existing visualization techniques? So let me continue to the next section. I uploaded to the e-class about this materials. This is about the data preprocessing. In the data preprocessing, so the book mentioned that there are 4 types of tasks. Okay. The first is data cleaning, and then data integration, and then data reduction, and data transformation. So we are going to discuss these things in this week and next week. So what are the major tasks in data processing? As I mentioned in the early part, we have data cleaning. Data cleaning means we want to fill in missing values. We want to smooth noisy data. We want to identify or remove outliers. Or we can resolve some inconsistency. Clean. So, we do not want to include dirty data. So those are some examples. Data integration. When you do the data analysis, your data might be in multiple databases. Maybe your database is one in Korea, another database is in USA, or maybe one database is using Oracle, another database is using MySQL. So you need to integrate to make a good data analysis. We can also use some concept about data cubes or files. And there are also issues about data reduction. When your data is too big, okay, you know about big data. But usually big data is not about the efficient data analysis. So we want to reduce. We call it, this is the data reduction. Let's say you have 1 million data. I have 1 million data and I have 1,000 data. If the result of 1 million data the same with the 1,000 data, should I use the 1 million data I don't need to use the big data if the result is the same. So we can just use the small amount of data, and there are some techniques to reduce the big data. We call the dimensionality reduction or numericity reduction, and we will learn some concept about data compression. Data transformation. So we will learn some concept about the normalization and concept hierarchy generation. First is about data cleaning. What is data cleaning? You know, when we want to do cleaning, 청소. So it's the same. In the data, there can be, there are a lot of dirty data. Data in the real world is dirty. Lots of potentially incorrect data. For example, instrument faulty, instrument errors, or human or computer errors, or transmission errors. For example, some data might be incomplete, not complete. It lacks attribute values. It lacks certain attributes of interest. It contains only aggregate data. For example, maybe some of the data about occupation is null or missing. So we call this is incomplete, not complete. Some data might be noisy, containing noise or errors, or maybe we call it outliers. For example, your salary is -10. Of course, this is not making sense. Okay? Salary may not be negative. It should be positive. Inconsistent, containing discrepancy in codes or names. For example, in the column 8, the age is 45, but the birthday, Sangil, it is January 1st, 2015. Is it right? If someone has the birthday on 2015, and let's say today is 2022, then this year he or she will be 7 years. But his age is 45. So it is not consistent. Then, yeah, this kind of data, you need to clean it. Sometimes when you use rating, maybe some website, they use the rating with numbers, 1, 2, 3. But other website, they use rating with letters, A, B, C. So if you want to integrate, then it is not consistent. There can be some intentional data. It is to disguise the missing data. For example, if you get the promotion, 광고, so let's say the marketing person wants to know your birthday, but you do not want to share your information. So there will be some missing data on the birthday. So the marketers will put the intentional birthday as January 1st. So everyone will have January 1st as their birthday. And in this case, yeah, of course, this is dirty data because it is intentionally to make the data exist. Let's discuss about the incomplete or missing data first. Data is not always available. Many tuples have no recorded value for several attributes. Let's say customer income in sales data. People do not want to share their income. So there might be a lot of missing data in the attribute income. There are some other factors about the missing data. Maybe the equipment malfunction, equipment errors. When the equipment errors, we cannot extract some data, or inconsistent with the other recorded data and delete it. So maybe we do not know that some other data already exists. So we just delete, remove the data from the database, and then it is missing. Or data not entered due to misunderstanding. Because I do not know what should I fill on that data, so I leave it blank. Certain data may not be considered important at the time of entry. Sometimes when you go to the mart, when you apply your, for example, hewan gaib, maybe you can just enter your personal information, just name, Yudipun Bono, and maybe your birthday, and finish. They do not ask your address. So your address will be empty. But it is important. So there can be, we can say that is the missing data. Or not register history or changes of the data. So this kind of things happen and it causes the incomplete data. Missing data may need to be inferred. Inferred means we need to check what is the factor of this missing data. So I would like to discuss 3 types of missing values. The first is missing completely at random. We call it, this is MCAR. The fact that a certain value is missing has nothing to do with its assumed value and with the value of other variables. Maybe it is too long to make you understand. So let's see, this one is the complete data. And this is the incomplete data. If you look at the age, this is the column of age, and then this is the column of IQ score. So all data are completed here. But the incomplete data, here is missing. Here is missing. Here is missing, 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 and missing. So those missing values are random because there is no such pattern. There can be a lot of things. The cause can be like the instrument fault, or maybe the internet connection errors, or maybe because of this data, we don't know. Okay. But it is totally, completely at random. The second type of missing values, we call it missing at random. MAR is that the values of the missing data can somehow be predicted from some of the other variables in the dataset. For example, data is missing due to the connectivity in the rural areas. Maybe because it is in the rural areas like Sigul, there is no internet connection. So all the data in the rural areas are missing, but the data in the city is okay. That can happen. Income data is missing for respondents on certain ages or gender. Let's say the youngers, they do not have the income. So all youngers' income are missing. So we call this is missing at random. Somehow we can predict. So let's say in this example, this is the complete data. And this is the incomplete data. We have the missing value here. So can we see some patterns about the missing values? Can we predict something? We can see that the IQ score for old person exists, but the missing data happen on the young people. Okay. So in this case, we can predict or we can say something that, okay, the missing data happen to the young people. But at the previous example, we cannot see any pattern. So in this example, we cannot see any patterns. It is totally random. But in this case, the incomplete data or the missing data, we can somehow predict. Okay, yeah, the youngers do not want to share the IQ score. Or maybe the young people, they do not do the IQ score. There's another type, we call it missing not at random, MNAR. MNAR data is the most complicated one, both in terms of finding it and dealing with it. So it is complicated to understand this MNAR, missing not at random. Let's say data is missing due to the intention manner of driver A. Maybe when you have a company, a logistic company, okay? So when you see there is a missing data, the missing data always happen because of the driver A. Then it is unintentionally missing data. Or maybe data is missing when the city equals to Surabaya. So Surabaya is a city name in Indonesia. Okay. Maybe because of the city names, yeah, there are a lot of missing values. So if we look at this data, we have the complete data, and then this is the incomplete data. What can you see about the missing values in this data? Is this a missing, not a random? What is the pattern about the missing value here? Okay, that's good. So the missing value happen on the people who has the IQ score below 110. So it means the people who has low IQ score, they do not want to share the data. Okay. So this is very difficult to check. Okay. And because this is missing not at random. if you can find this kind of missing values or the patterns of these missing values, then you can replace the data later on. So the assumption and the missing data mechanism, as you know, the data that we are going to deal with is the column and rows. So the missing data can happen like this one. When we have the instances, okay, so I hope you still remember the instances are the rows, attributes are columns, and it can happen like this one. The missing value is here, the missing value is here, 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 here. Yeah. If you have this kind of missing values, it will be more complicated, okay, to find what are the reasons. What is there any random in these missing values? Is it MNAR? Is it MCAR or is it MAR? Yeah, it is more complicated. So how to handle the missing data? There are at least three things. Okay. The first is to ignore or to remove. So it means we will just delete. We do not consider the data into our analysis. Usually done when class label is missing, especially when we want to do the classification. It is not effective when the percent of missing values per attribute varies considerably. So we will check what is the meaning by this one. The second way is to fill in the missing value manually. So we will fill in one by one. But if your data is 1 million, of course it is tedious. Tedious means time consuming. And it is infeasible, not feasible, because you need to check one by one. Or the third one, we can fill in it automatically. We can put the global constant. For example, we call unknown. We can use the attribute mean. We can use the attribute mean for all samples belonging to the same class. Or we can use the most probable values, maybe using the probability or the mode. So let's see some examples. I have three data. Okay, this is the first, this is the second, this is the third. In the trial one, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 10 rows and I have 4 columns. 1, 2, 3, 4. NA means not available. Not available, not available, not available. And then we have not available, not available. If you want to delete this data, you cannot just delete this one and this one. When it is not available, it means you need also to delete this. When you delete, when you delete this one, it means we eliminate the individual 1 and 2. So we have 8 multiplied by 4. How we calculate this one? We have 4 columns, 1, 2, 3, 4. And we keep 8 rows. 1, 2, 3, 4, 5, 6, 7, 8. So in this case, we still have 32 data and we have 20% loss if we delete the data. What about the second? The NA is here. There are a lot of NA in this column. So the most possible values or the most possible way to delete is just to delete Y1. We just remove this column. And if we remove this column, then we can keep 30 data. Okay, 1, 2, 3, 3 columns and 10 rows. So the removal is, yeah, we just lost 20%, 25%. But what about this? We have NA here, we have NA here, we have NA here. If you want to delete the 3 columns, it is not useful because you just have only 1 column. Then, okay, I want to delete this because it is NA, it is NA, and it is NA. Then if we delete it, all those, we have only 16 data. So we have 60% loss. So the mechanism, if we want to delete or if we want to remove the data, we need to make sure that the amount of missing value is small. If the amount of missing values are varied like this one, we have a lot of loss. If we have a lot of loss, then we cannot do a good data analysis. I think I will stop here. I will continue this on Thursday.